So here we are, we're doing such an interesting and fundamental measurement here that we can do with very basic equipment. And right now we're trying to figure out both the particle density and the bulk density of loose sand, right? And we could do that by using a scale or a balance, right? Some sort of thing to measure mass, a couple of graduated cylinders to be able to measure volume of both water and solids, and a really important thing, the transitive property of water, right? If we remember back in chemistry, transitive property of water was 1 gram of water is equal to 1 milliliter is equal to 1 cubic centimeter. And that transitive property is really important when you're trying to estimate things like the volume of pores in that sand and a lot of other things. We use it a lot more than we think. So we're going to be using that. We're weighing out a sample of 40 grams. We weighed and we put the sand in and we measured the volume that the sand took up when we packed it. We weighed out 30 milliliters of water and poured it in. Like I said, we had 40 grams of sand that we weighed out in this boat. We weighed it on the electric scale, and then we tested the triple beam balance. You know, you hear about balance, a balance or a scale. This was the way that it worked, right? You used something that was in balance with something else, a weight that was known, and you could compare things based on mass. So here we did a cross comparison of the weight from the electronic scale and the mass on the triple beam, and it was great, right? It comes right up to 0, and it balances out perfectly, or is good at the level that we need to work at. So we took 40 grams of sand, we poured it into the graduated cylinder, we weighed out 30 milliliters of water, we poured them together, and we ended up with a 46.5 milliliter volume. So total volume of solids plus water was 46.5 milliliters. I just wanted to point out that there was a moment there where there was gas bubbles trapped in the bottom. Just because there's pores and there's sand and the ability for the water to get in doesn't mean that things can't get trapped down there. We literally had to get out the glass stirring rod and poke down in there to get the bubbles of the material or the gas that was atmosphere that was trapped down in there. Always fun just to observe things and think about what's happening and then have to figure out how to fix it, right? So from that, we'll go do the calculation up on the board. Cool. Hey, all right, so now we got the data from our sand and our water and the changes in volume. And now we can work through the sheet that we added to the chat as a link, and we can go through and fill out A through G, pretty straightforward. And then we'll have to do H and I as a thought experiment together, and then we'll work on J and K in the discussion group. I want to get you to think about how you would calculate the percent sand solid, the percent pore space, and then what about the applications? What if you needed to buy volumes of sand? How much does the volume of sand weigh? And what if it gets wet? Let's figure that out later. But let's go back to this really quick. Let's just work you through a couple of these. So we know we started off with A, which is 40 grams of sand. Then we put that in a graduated cylinder, and we got 25.5 milliliters or cubic centimeters of volume. Then we can calculate the density of that material pretty easy. Mass divided by volume. In this case, it's 1.57 grams per centimeter cubed, right? Then we added a known quantity of water. We added 30 milliliters of water, which would also weigh 30 grams, right, with that 1-1-1 relationship. Now, when we added the water to the sand up here, it ended up being 46.5 milliliters, right, or centimeters cubed, right, either one. So that tells you that the difference between 30 and 46.5, 16.5, is the mass of sand, the actual volume of sand. The water couldn't get in between those particles. It was able to go in between the rest of it, but that 16.5% of 25.5 was sand solids, and that's why the water column went up 16.5. Okay? You just got to remember that sand density is 2.65. We'll get to that later when we talk about bulk density a little bit more. Now, we have all the pieces we need to be able to calculate H, I, J, and K as a thought exercise in groups. So let's go in there and do that.